So hello to all. So in this video we try to draw a distribution curve for a data set. Okay, so let's start. We'll go to spreadsheet, and then you can see here there's a column E, okay, which contains data. Okay, so the data is from 50 to 150 here, and for this we have to draw a distribution. So what is the first step? First step is to calculate the mean. So how are we going to do? So for that we have to calculate the mean. So for that we'll write equals to average, okay, and then open parenthesis, and then select the column E and then enter. So the mean comes out to be 100 for this particular data set. And in order to calculate standard deviation, you have to write std ev dot p and then open parenthesis, okay, and then you have to select the column and then enter. So the standard deviation comes out to be 29.43, okay, so for this particular column. And then we are going to plot a normal distribution curve. Okay, so for this we have to calculate the probability density function for each data point. And the probability density function, okay, for a normal distribution curve, it's a very much complex formula. So for this I just want to give you a glimpse that how the formula looks like. So I can see here for normal probability density function, the fx, this formula is how much looking complex. So it is very much difficult to um, calculate the value for each data point. It's very much difficult to calculate the value of each data point manually. So the Excel will help us actually. So how are we going to do? So for this we have to write equals to, so we have to write norm dot dist and then open parenthesis, and then there are four arguments. That is, first is x, that is a data point we have to give. So select the data point, okay, and then comma, and the second argument is the mean. Okay, so for this we have to select the mean, okay, and the function f4, you have to click f4, okay, to stabilize the cell, and then comma, and then the third parameter is what, standard deviation, and for this we have to select standard deviation and then f4, okay, and then again comma, and then for this you have to select false, okay, and then enter. So this is the value of a function for a data point 50. Okay, so for all data points we just have to drag it down, you'll get the value. Okay, now the next step is, suppose if you want to see how your distribution looks like, so for that you have to select column E and then F, and then go to insert and then chart, and then you can see here your normal distribution curve. So you could argue that, so what is the importance actually? So actually we want to know the probability. Okay, so suppose if you ask you, so what is the probability that the number lies between 60 and 80? What I've said, what is the probability that the number lies between 60 and 80? Okay, what is the probability? So the standard normal probability distribution will help us, in which what we do, we convert all these scores to Z, that is a standard score. Okay, so for that, what is the probability that the number lies between 60 and 80? So for that, we have to convert this 60 to the standard score. What is the standard score related to 60? What is the standard score related to 80? So let's do that. We have to calculate it. So for that we have to write equals to standardize and then open parenthesis. What is the first argument? X, that is data point. What is data point? 60. Okay, comma, what is the mean? 100. So I have to give the mean, and then what is the standard deviation? Standard deviation comes out to be 29.43, and then enter. So the Z1 standard score for 60 comes out to be minus 1.35. Okay, and for your knowledge, what is standard score? Standard score is nothing but it just gives us the information that how much standard deviation our data point is away from the mean value. So it is minus 1.35 standard deviation away from 100 in negative direction. Okay, so now we are ready to calculate the value of standard score for 80. So standardize. Okay, and then we have to give 80 and comma mean and then comma the standard deviation. Okay, and then enter. Okay, so now our work is to calculate the area actually, because the area will gives us the probability, because of continuous probability distribution the probability is calculated by the area actually. Okay, so now we have to calculate the area. Okay, so for this we have to write equals to and then norm dot s. Okay, s dot dist. Okay, and the value of z it will take, we have to give, and then we have to give as true. Okay, true and enter. Okay, so it comes out to be 0.15, and then we have to just drag it. Okay, so it's 2. Okay, yes, it is true. And then desired area we have to calculate as j2. I'll explain how it is calculating. J2 minus to write I2. Okay, and this is the desired area, means the probability that the number is between 60 and 80, where 60 and 80 is inclusive. Okay, so the probability is 15.82%. Okay, so I'll explain. So the z1 value is minus 1.35 and the z2 is minus 0.67. Okay, so actually what is happening here, that okay, okay, so this is, so this is minus 1 sigma. Okay, so for a standard normal distribution we are converting all the score to a standard score. So this is plus 1 sigma. Okay, so what is z1? Minus 1.35, so it is must lying here, minus 1.5. Okay, so this is what, minus 1.35. Okay, and the value of z2 is minus 0.67. So this is between 0 and minus 1, that is something about you can say here. Okay, so actually this area we have to calculate. This is what, minus 1.35. This is minus 1.35. Okay, minus 1.35, and this is what, this is 0 minus 0.67. Okay, 6793. Okay, so this area we have to calculate. So how Excel has calculated? So what it has done, that it has calculated for area to the left of z1. So this is what, this is z1 to the left. So whatever the area to the left of the z1, that is this portion, it has calculated. Okay, this area has calculated, this area is what, this area is, it has calculated. Okay, we have to see, let me just track. Okay, okay, so what is this area? This area is 0.1584. Okay, and now what is the area to the left of this, minus 0.6793? It has calculated 0.316. So can, okay, suppose pink, or you can say uh, violet. Okay, so what is the area to the left of minus 0.6793? So this area. Okay, so the violet minus pink, you will get the green area. That is the desired area that we have to get. Okay, so the violet comes out to be what? The violet comes out to be 0.3167, and minus the pink area comes out to be 0.15, and we have just subtracted both the cells, and we have got as 0.1582. So that's how we are actually getting the desired area. And we know the area in probability distribution curve helps us to, in a continuous probability distribution, helps us to give the probability. Okay, so the probability comes out to be 15.82%. Okay, sorry. Okay, 15.82%. So that's all for this video, and thank you.